Hello everyone, once again welcome back to my YouTube channel. Today we are going to solve the question paper of CBSE class 12 subject physics series SSJ/1 set number 4, and the question paper code is 055/1/4. I already know that you have known the answers so far, but now it is time to analyze how difficult or easy the question paper was. So let us jump to the first question straight away. And the first question is, an electric dipole placed in a non-uniform electric field will experience. We have to focus that the dipole is placed in a non-uniform electric field. Now, if the dipole is placed in a non-uniform electric field, it is going to experience force as well as torque. So it is a straightforward question. If it would have written that electric dipole is placed in a uniform electric field, then it would have experienced only a torque. Now, second question is, let N1 be the number of electric field lines going out of an imaginary cube of side A that encloses an isolated point charge to Q. So the information given is that we are having a flux coming out of surface. Flux coming out of surface means number of electric field lines coming out of closed surface. So flux coming out of closed surface is equal to charge upon epsilon naught. The charge enclosed by that surface divided by epsilon naught, that is N1 is equal to flux through the cube is equal to charge enclosed by the cube, that is 2Q divided by epsilon naught. Also, the other information which we are having is that N2 be the corresponding number of and imaginary lines coming out of the sphere of radius A that encloses as an isolated point charge 3Q. So now the information is number of field lines coming out of the spherical surface. N2 is equal to phi, that is flux coming out of the sphere is equal to charge enclosed by the sphere, that is 3Q upon epsilon naught. Now they just want to calculate us, to calculate N1 by N2. So N1 by N2 is equal to 2Q upon epsilon naught divided by 3Q upon epsilon naught. We can easily cut this. So we are having N1 upon N2 is equal to 2 by 3. So B is the correct option for question number 2. For question number 3, we are having a circuit in which P is not equal to R and the reading of the galvanometer is same whether the switch S is open or closed. This S switch is shown open. That means no current is flowing through this. IS is equal to 0. But if they have written, if we put this switch on, that is if we close this circuit, then again current from the switch is 0 because there is no change in the reading of the galvanometer. So that means in either case the current coming out of the switch is 0. So if we will redraw this diagram like this, P and Q, here we are having R and G, then this is the external source of potential. So now we are having I current. If flowing through this circuit at this junction point, current will divide into two parts, I1 and I minus I1. That means I1 current will flow through P and the same current will flow through Q. And similarly, the current I minus I1 which is passing through R will flow through the galvanometer, that is I minus I1. That means current passing through R is equal to current passing through G. Therefore, B is the correct option for question number 3. Now, fourth question is, we are having two wires A and B which are made up of same material. So this is the word which is needed to be focused, having length in ratio 1:2 and diameter in ratio 2:3. So length of wire A, here we are having length of wire A is equal to X. Let's say it is X. So if we will take length of wire A to be X and length of wire B will automatically become 2X because the ratio is 1:2. And they are having the diameters in the ratio, that is diameter of A is equal to 2Y and diameter of B is equal to 3Y. Or from this information we will just convert it into radius of A is equal to Y and radius of B is equal to 3 by 2Y. Now the information what they want us to do is that these are connected in series. If these two wires are connected in series, that means same current is flowing through the wires, that is current through A is equal to current through B. Therefore, from Ohm's law, we know that I is equal to V upon R. That is potential developed across A upon resistance offered by A is equal to potential developed across B upon resistance offered by B. Why I have written this thing? Because the next instruction says the ratio of potential difference is VA upon VB. That means they want us to calculate VA upon VB. So cross multiplying these, we are having VA upon VB is equal to RA upon RB. Just need to calculate RA and RB and we will be able to find this ratio. Here in this answer, now we know resistance is R is equal to rho L upon A, so VA upon VB is equal to, using the formula rho L upon A. Because the wires are made up of same material, resistivity will remain same, but lengths and areas are different. Upon rho, length of B upon area of B. So we can cancel out resistivity, and rearranging we are having LA upon area of A multiplied by area of B upon length of B. Substituting the values, we are having length of A, x, and area of A, pi r square, pi radius of A into and square, multiplied by area of B. Area of B is pi radius of B square divided by length of B. Length of B is 2x. So we will put 2x. Here we can cancel x, we can cancel pi. So we are left with VA upon, here I have written VA. So VA upon VB is equal to RB square upon 2 multiplied by RA square. Now we are having RB is equal to 3 by 2y. So 3 by 2y whole square upon 2 multiplied by y square. So we are going to solve this part. So we have 9 upon 4 y square upon 2 into y square, and we can cancel out y, so we are left with 9 upon 4 into 2 is equal to 9 by 8. So D is the correct option for question number 4. It was a little bit lengthy question, but it required a little bit of efforts. Only general information was required in order to solve or in order to handle this question. So next, when we come to question number 5, we are having two moving coil galvanometers G1 and G2 having the following particulars respectively. So number of turns in the first coil is N1 is equal to 30. Area of the first coil is 3.6 into 10 raised to power minus 3 meters square. Magnetic field B1 is equal to 0.25 Tesla. However, for the second galvanometer, we are having number of turns 42, area 1.2 into 10 raised to power minus 3 meters square, and magnetic field 0.50 Tesla. They just want us to calculate the ratio of current sensitivities. So the current sensitivity SI is equal to NBA upon K. So this is the formula for the current sensitivity. We just need to apply these formulas, that is G1 upon G2. See, sensitivity of the first galvanometer, I have mentioned it with the G1 and G2 respectively. That is G1 upon G2 is equal to N1 B1 A1 upon K, because they have mentioned the point the spring constant is same for both the galvanometers. So instead of writing K1 or K2, I have written K, because K1 and K2 are equal, divided by N2 B2 A2 divided by K, and we can cancel out K. So the ratios are N1 B1 A1 divided by N2 B2 A2. So the things are quite simple. We just need to put the values, that is 30 multiplied by 3.6 into 10 raised to power minus 3 multiplied by 0.25 divided by 42 multiplied by 1.8 into 10 raised to power minus 3 multiplied by 0.50. So here we are having direct cutting. So 18 and 36 2, so we are having 30 upon 42 final answer, and we can further solve it like 6 5s are 30, 6 7s are 42. So 5 ratio 7. So A is the correct option. And now moving to the next question, sixth question, that is a current I is flowing through the loop as shown in figure. Here M A is equal to R. So this radius MA is equal to R and MB is equal to 2R. And if I talk about this radius, so this radius is equal to 2R, and they want us to calculate the magnetic field at the center of the loop. That means we are already given, we have to find what is multiplied. X is multiplied by mu naught I upon R. So what is the value of X? That is what we need to calculate. So I'm going to erase it, and first of all we need to consider the first sphere. So first sphere, which one is our first sphere? Our first sphere is this. So this first sphere is having three parts. So these three parts are contributing in the magnetic field at the center. Why this sphere is having three parts? How I came to know this? Because this line, that is MA and MD, it is representing the fourth quadrant. So if it is representing the four quadrants, that means this circle has three equal parts which are contributing in the magnetic field. So magnetic field due to these three parts, so we are having three equal parts. That means we are having magnetic field at point M due to the circle of radius R, because the circle has four equal parts, out of which one part is not contributing, this one part is not contributing, but other three parts, that is from D to A, this part is contributing in the magnetic field. So magnetic field is 3 by 4 multiplied by, so magnetic field just because of circular loop is mu naught I upon 2R, and magnetic field at point M, magnetic field at point M due to circle of radius 2R. So this is the circle, and only 1/4 part of this circle is contributing to the net magnetic field at M. So M due to radius 2R, it is equal to 1 by 4th and mu naught I upon 2, but the radius this time is 2 times capital R. So this is the value. So total magnetic field is equal to 3 by 4 into mu naught I upon 2R plus 1 by 4 multiplied by mu naught I upon 2 multiplied by 2R. So the things which are common will be taken out, that is mu naught I upon 2R will be written outside, and we are left with 3 by 4 plus 1 by 4. Sorry, 3 by 4 plus 1 by 4 into 1 by 2. So it is equal to 3 by 4 plus 1 by 8. And outside the bracket, we are having mu naught I upon 2R. So it is mu naught I upon 2R multiplied by 6 plus 1 divided by 8. That is 7 by 8. So I will just write it as 7 by 8. But they wanted us to calculate x multiplied by mu naught I upon R. So I have to multiply this 2 with 8. So instead of writing it in the form mu naught I upon 2R, I will write it as 7 upon 2 8s are 16 multiplied by mu naught I upon R. So that is, the answer is 7 by 16. So we can easily cancel out these two questions, these two options, that is 5 by 16 and 5 by 16. That means now we are having two remaining options, 7 by 16 and that is out the plane of paper or into the plane of paper. So if we will apply right hand curl rule, if you will place the right thumb of your right hand in the direction of flow of current and curl your fingers will move inwards. So here the fingers are moving inwards. Now if you will place the thumb of your right hand in the direction of flow of current over here, then again your fingers are moving inwards at point M. That means your fingers are entering into the plane of paper. So D is the correct option in this question. Now, seventh question is, a capacitor and an indicator are connected into two different AC circuits with the bulb glowing in each circuit. We are having a capacitor and we are having an inductor. These two capacitors and inductors are connected in two different AC circuits and both are having a bulb connected with them. The bulb glows more brightly when the number of turns in the inductor is increased, the separation between the plates of the capacitor is increased, an iron rod is introduced into the inductor, or a dielectric is introduced into the gap between the plates of the capacitor. So here we have to be careful. Most of the most of my students have marked it as an iron rod is introduced into the inductor, but this is not a right option, because we know XL is equal to L omega. When we will introduce a iron rod inside the inductor, then at that time L will increase, and if L will increase, correspondingly XL will increase. But Xc is equal to 1 upon omega c. So when the dielectric is introduced into the gap between the plates of the capacitance of the capacitor will increase, therefore Xc will decrease. So if Xc will decrease, bulb will glow more brighter. So D is the correct option for question number 7. Now, a pure inductor of 318 millihenry and a pure resistor of 75 ohm are connected in series to an AC voltage source of 50 Hertz. The voltage across 75 ohm resistor is found to be 150 volt. The source voltage is, now what we are having, we are having this information, that is L is equal to 318 millihenry. Then resistor having resistance of 75 ohm, these are connected in series, and we are having frequency nu is equal to 50. We will calculate omega, it is equal to 2 pi nu. It is equal to 2 multiplied by 3.14 multiplied by 50, that is 3.14 multiplied by 100 is equal to 314. So we are having omega is equal to 314. I will erase rest of the part. I will only write omega as 314. It was actually a verbal calculation. And now the voltage across resistor is 150 volt. So we are having VR is equal to 150 volt, as they are saying that inductor and pure resistor are connected in series, that is voltage across L plus voltage across R should be our answer. But it will not be our answer, we have to modify it a little bit, but we will get into that later. And first of all, let us see what is the amount of current flowing through the resistor, because in series circuits same current flows through the different elements. That is why we know V is equal to IR from Ohm's law. So V is equal to 150 in case of resistor is equal to I. We do not know what is the current flowing through the resistor or through the inductor. So we need to calculate it multiplied by 75. So I am using shortcut. So I is equal to 2 ampere. So that means if current is equal to 2 ampere, which is flowing through the resistor, same amount of current is flowing through the inductor. That means in order to calculate VL, we need I into resistance offered by the inductor. So we are having the value of current, but we do not know the value of resistance offered by the inductor, that is inductive reactance. We need to calculate inductive reactance, and in order to calculate inductive reactance, XL is equal to L omega. We will put the values, that is 318 into 10 raised to power minus 3 into omega, which is 314. So the calculation comes out to be 0.318 multiplied by 314. So here it comes a difficult part, that you have to invest a little more time in order to find it. So I'm going to use a shortcut once again. So the answer is nearly equal to 200. Therefore voltage across inductor is equal to 2 multiplied by 100 is equal to 200. But in this case you cannot use that source voltage is equal to voltage across L plus voltage across R. There is a reason for that, because in this case our phasor diagram is different. According to our phasor diagram, if this is the this is the voltage developed across R, and this is the voltage which is developed across inductor, then the net voltage, this is V. So that means we have to use the formula V is equal to under root of VL square plus VR square. So it comes, on solving, it comes out to be 200 square plus 150 square. When you will solve it, you will get the answer 250 volt. So D is the correct option. So this was the basic concept. Again, this eighth question is the question which is a little bit lengthy and it requires more calculations, but Again, it was a simple question. You only need to know the concept beforehand. Now, the question ninth is the electric field at a point on the axis of a short electric dipole at a distance x from the midpoint of the dipole is proportional to. Here we are having a short dipole. Here we are having a short electric dipole, and and we have to find the value of electric potential. And for the electric potential V, we know the formula. V is equal to 1 upon 4 pi epsilon naught q upon x. But when it comes to the dipole, that is potential of the dipole, then the formula turns out to be 1 upon 4 pi epsilon naught. And in case of axial line, on the axis of, so on the axial line, the formula is 2p upon x square. That means V is inversely proportional to x square. So it was all related to direct formula only. So D is the correct option. It was hardly consuming any time. If you will be knowing the formula, you could have attempted right. Then 10th question is, let F1 be the magnitude of the force between two small spheres charged to a constant potential in free space, and F2 be the magnitude of force between them in a medium of dielectric constant K. Then F1 and F2 is. So you just needed to draw this condition, that is two charges Q1 and Q2. This is the condition without having any medium, that is only air as a medium, distance r. So F1 is equal to 1 upon 4 pi epsilon naught q1 q2 upon r square. Now in second case, just fill this space with a medium, that is F2. It is equal to 1 upon 4 pi epsilon q1 q2 upon r square. And now instead of writing epsilon, we know epsilon is equal to k epsilon naught. So we will put k epsilon naught over here, and then just divide these two equations. 1 upon 4 epsilon naught, 1 upon 4 epsilon naught, q1 q2 upon r square, q1 q2 upon r square, cancelling out this. So we are left with f1 upon f2 is equal to 1 upon 1 by k is equal to, so it is equal to further k. So on solving, we are having f1 upon f2 ratio is equal to k. So B is the correct option. Then 11th question is, infinity resistance in a resistance box has. I hope many of you got confused with this question, because in the first go even I got confused for the very first time. But then again rereading it, we are having infinity resistance in a resistance box has. So when we are having a resistance box, that is the resistance box which we make use of when we have to conduct the experiments. In that resistance box, we are having here infinity resistance. So what does this infinity resistance, what is this infinity resistance? So this infinity resistance is just a gap. It is only a gap in the resistance box. Now 12th question is, a battery of 15 volt and negligible internal resistance is connected across a 50 ohm resistor. We are having a battery which is having a 15 volt and a negligible internal resistance is connected across 50 ohm resistor. The amount of energy dissipated as heat in the resistor in 1 minute is. So we know the formula H is equal to I square RT, but we do not need I because we are given with the voltage, and we know I is equal to V upon R. So therefore this formula turns out to be V upon R whole square RT is equal to V square upon R square RT, and cancelling out 1 R, we are left with V square upon RT. Instead of using 1 minute, I am going to use T is equal to 60 seconds. So we have to put the values rest, that is 15 square upon 50 multiplied by 60. So cancelling out this, we are having 15 multiplied by 15 multiplied by 6 divided by 5. 5 3s are 15, and on solving, we are having 270 joule, that is B is the correct option. Then Lenz's law is the consequence of the law of conservation of energy. So it was a very direct question. We just needed to read the question and answer it. The vertical component of Earth's magnetic field at a place is 1 root 3, 1 by root 3 times the horizontal component. The information given is BV is equal to 1 by root 3 BH, and we had to calculate the angle of tip. So we have tan delta is equal to BV upon BH. It is equal to 1 by under root 3 BH divided by BH, and cancelling out BH, we are left with tan delta is equal to 1 by root 3. That is, we know tan delta is equal to, tangent has a value of 1 by root 3 when angle is 30 degrees. So tan 30, this implies delta is equal to 30 degrees. So B is the correct option. A long straight wire in a horizontal plane carries a current of 15 ampere in north to south direction. Let's say this is a long horizontal wire. First of all, you needed to make the directions. Mark it as north, south, and towards the right of north is east, and here is west. So this wire is carrying a current in the north to south direction. So north to south direction, and the current is 15 ampere. The magnitude and the direction of magnetic field at a point 2.5 meter east of the wire respectively are. So we had to find over here the value 2.5, the distance of 2.5 from the wire, 2.5 meter from the wire in the east direction. So first of all, you need to place the thumb in the direction of flow of current. Place the thumb of your right hand in the direction of the flow of current and curl your fingers. You will find that your fingers will coming out of this point. It will be coming upwards towards you. That is, it is vertically upward. So two options could be eliminated, downward and downward. So we had to choose the right option between this and this. So we are for sure about the direction, that is, it is vertically upwards. But now elimination round is over. We just have to find the value over here. So in order to find the value, we need to use a direct formula. B is equal to mu naught I upon 2r, 2 pi r, sorry, it's 2 pi r. So mu naught is 4 pi into 10 raised to power minus 7 multiplied by 15 divided by 2 pi multiplied by r, that is 2.5. That is, pi and pi should be cancelled, and here we are having 2 multiplied by 2, that is we are left with 2 into 10 raised to power minus 7 multiplied by 15 divided by 2.5, and 30 upon 25 into 10 raised to power minus 6, and we are having, it is equal to, further solving, 5 6 are 30 and 5 5s are 25, and we are having 1.2 into 10 raised to power minus 6 is equal to 1.2 micro Tesla. That is, A is the correct option over here. So C is the wrong option. The only option we are left with is A. So that means you needed to know the formula only in order to solve question number 15. Now when it comes to question number 16, the EMF induced in a 10 Henry inductor in which the current changes from 11 ampere to 2 ampere in this time, the n into 10 raised to power minus 1 second, that is, it could be written as 0.9 second. So we had to find the value of EMF induced. Induced EMF is equal to L di by dt, again direct formula. Change in current, L, change in current is 11 minus 2, and change in time is 0.9. So we are having 10 multiplied by 9 divided by 0.9, and we are having 10 into 10 up into 9 upon 9. I have just removed the decimal from here. So cancelling out 9, we are having 10 raised to power 2. So C is the correct option. Now, when it comes to question number 17, a charge Q is placed at the center of the line joining two charges, small q and small q. We are having two charges, that is small q, and we are having a separation as R. So capital Q is placed at midpoint, and in the system of three charges, when this system will come in equilibrium, what we need to do, we need to calculate when this system will be in equilibrium. And in order to calculate that when the system will be in equilibrium, we have a condition that force on Q and Q, force between this and this, plus force between Q and capital Q, that is force between this and this or force between this and this sum should be equal to 0. This implies force between Q and Q is equal to negative of force between Q and capital Q, that is 1 upon 4 pi epsilon naught Q upon R square is equal to minus 1 upon 4 pi epsilon naught small q capital Q upon R by 2 whole square, and we can cancel out 1 upon 4 pi epsilon naught on both sides. We are left with small q square upon R square is equal to small q capital Q upon R square by 4, and instead of writing 4 in division, I will put it over here in multiplication. R square we can cancel one small q, so this implies small q is equal to 4 times capital Q, or we can say capital Q is equal to, we could not miss the negative sign because it is already there, so minus 4q. So capital Q is equal to minus small q by 4, so the condition is capital Q should be equal to minus q by 4, so D is the correct option. Then in question number 18, electric flux of an electric field E through the area dA is given by, it is a very straightforward formula, that is E dot dA. So this is C option, which is again a direct question. And then 19th question is, in a potentiometer experiment, the balancing length with a cell is 120 centimeter. So if we are having balancing length L1 is equal to 120 centimeter, when the cell is shunted by a resistance of 1 ohm, capital R is equal to 1 ohm, with the balancing length 40 centimeter, then the balancing length is having 42 centimeter, then the internal resistance small r, just use a direct formula, R is equal to L1 minus L2 whole divided by L2 multiplied by R, that is 120 minus 40 divided by 40 whole multiplied by 1, it is equal to 80 divided by 40, and we are left with 2 ohms. So the internal resistance of the cell is 2 ohm, that is D is the correct option. An electron is projected with velocity v along the axis of the current carrying long solenoid. If we are having this long solenoid and the electron is moving along the axis of this long solenoid in this direction, which of the following statement is correct? So in this case, electron is moving in the direction of the magnetic field, therefore it will keep on moving in the same path without getting deflected. So D is the right option. The electron will continue to move with the same velocity along the axis of the solenoid. And now, if the speed v of a charged particle moving in a magnetic field B, where v is perpendicular to B, is halved, then the radius of the path will be. We know that in case of circular motion, we are having centripetal force, that is mv square upon r is equal to qvb. So this is the formula which we have related. We just had to cancel v over here, so we are having cross multiplying, r is equal to mv upon qb, that means r is directly proportional to v. Now it is written that the velocity is halved. If we are having new, then what will be the value of new radius? Then new radius r dash is equal to m v dash upon qb, other factors remaining same, so instead of writing v dash, we will write v by 2 because velocity is halved. New radius is also getting halved, so we are having the correct option, it will become half, so D is the right option. Then a metallic plate is getting heated. We are having a metallic plate and it is getting heated. Which of the following statements is incorrect? It is placed in a space varying magnetic field that does not vary with time. So the metal plate which is getting heated, it is placed in a space varying magnetic field that does not vary with time, is the incorrect statement. Other statements, that is direct current is passing through the plate, is correct because when the metallic plate is heated up, the ions are moving in the same direction, so it is having a direct current flowing in it. And alternating current is passing through the plate just because the movement of the ions and the changing of the field is happening, therefore we can also say an alternating current is passing through it. And it is placed in a time varying magnetic field. Definitely if the fields are changing, then the plate is already placed in a time varying magnetic field, so A is the incorrect option. Then we are having the 23rd question as, in an AC circuit, the applied voltage and resultant current are E is equal to E naught sine omega t and I is equal to I naught sine omega t plus pi by 2 respectively, the average power. So when we see this equation here, we are having phase difference of pi by 2, We know that current leads the EMF by pi by 2 in case of capacitor, and it is a very basic concept. In case of capacitor, the average power consumed is 0, so D is the option. The speed acquired by a free electron when accelerated from rest through a potential difference of 100 volt is, we have to calculate the amount of speed which is acquired by the electron when it is accelerated through a potential difference of 100 volt. That is, we have to apply the formula half mv square energy is equal to q into v. So half into mass of electron, I will put m over here right now, v square is equal to charge on electron 1.6 into 10 raised to power minus 19, and the potential is 100 volt multiplied by 100. So we have 1.6 into 10 raised to power minus 14 is equal to half mv square. So we have to calculate v square. It is equal to 2 into 1.6 into 10 raised to power, sorry, no, it is not minus 16, it is minus 19. So charge on electron is 10 raised to power minus 19. I will keep on writing it as minus 17 because minus 19 plus 2 is minus 17. So 10 raised to power minus 17 upon m. Mass of electron is 9.1 into 10 raised to power minus 31 kg. When we will solve this equation and we will take the under root, that is v is equal to under root of all this thing, so all this stuff, that is 2 into 1.6 into 10 raised to power minus 17 upon 9.1 into 10 raised to power minus 31, we will come out to be having an answer of 6 into 10 raised to power 6 meter per second. So I have used the calculator and I have used a shortcut, so therefore I have been able to calculate it. Otherwise it is again a time consuming question because it needs some efforts to solve it. Then when it comes to question number 25, which one of the following is not affected by the presence of magnetic field? So we are having some things given in the options. So what is not affected when we are having a magnetic field around? A current carrying conductor. A current carrying conductor always experiences a force. It gets affected. It experiences a force in a magnetic field. A moving charge, it gets deflected. So whenever we are having a moving charge making an angle theta with the magnetic field, it gets affected. A stationary charge. So a stationary charge is the correct option because magnetic field has no effect on a stationary charge. So a rectangular loop, when it comes to rectangular loop, it starts rotating. Now in the section B, we are having questions from 26. And the question number 26 is 2-point charges plus 16q and minus 4q are located at x is equal to 0 and x is equal to L. The location of the point on x-axis at which the resultant electric field due to these charges is 0 is. So we have to find at which point uh, we are having resultant electric field is equal to 0. So if we will draw these charges, you had to draw these charges, that is plus 16q placed at x is equal to 0 and minus 4q placed at x is equal to L, that is the separation between these two charges is capital L. Now you need to identify this condition. Now the field due to bigger charge, that is 16q, it is all around and it is crossing the field of minus 4q charge, but minus 4q charge being smaller charge, its field is not crossing the 16q towards the left. It is not crossing it. It is like up to this point or this point, but the field due to 16q is extending and it is moving up to this point. So due to negative charge, field is inward, and due to positive charge, field is outward. So this will be the point outwards where the electric field, resultant electric field, will be 0. Let us say the distance of this point where the electric field, that is resultant electric field, becomes 0 lies at distance y. So now electric field at y due to charge placed at A is equal to electric field at y due to charge placed at B. So these fields should be equal. So that means we are having formula 1 upon 4 pi epsilon naught, and charge placed at A is 16 upon r square, that is L plus y square, because we are considering 16q which is placed at distance L plus y from the balance point. So L plus y whole square is equal to 1 upon 4 pi epsilon naught minus 4q. Instead of writing minus 4q, I will write 4q 16q upon y square. So the distance of this point of observation is y from this charge. And now cancelling out this q and q, 4 4s are 16. So we are left with 4 upon l plus y whole square is equal to 1 upon y square. It could be written as 2 upon l plus y whole square, and I am going to erase this condition because I need some space. So we have, okay, we have, it is equal to, this implies 2 upon L plus Y whole square is equal to 1 upon 2 whole square. Cancelling out this, we are left with 4 is equal to, sorry, it is not 4, it is Y, it is Y. So 4, uh, again 2 upon L plus Y is equal to 1 upon Y, and cross multiplying 2Y is equal to L plus Y, and this implies 2y minus y is equal to L, that is y is equal to L. That means from the origin of x-axis, the point x, the point which lies from where, the point at which electric field will become 0 will be L plus y, that is L plus y, and that is L plus L, and that is equal to 2L. So 2L is the point from the origin where electric field will be 0. An electric dipole of dipole moment 4 into 10 raised to power minus 5 coulomb meter kept in a uniform electric field of 10 raised to power minus 3 Newton per coulomb experiences a torque of 2 into 10 raised to power minus 8 Newton meter. The angle of the angle which the dipole makes with the electric field is, it is very straightforward question. So tau is equal to P E sine theta, and you could easily solve it, and on solving it you will get 30-degree, because you will be having at last sine theta is equal to 1 by 2, and sine theta is equal to, we know sine becomes 1 by 2 at sine 30, so sine 30, so sine theta, that is theta is equal to 30-degree. Then we are having three identical charges which are placed on x-axis from left to right. So let us place these three charges q, q and q from left to right, and these are identical, and with the adjacent charges separated by distance d. So the distance between these two adjacent charges is d, and the distance between these two adjacent charges is again d. The magnitude of force on a charge from its nearest neighbor charge is F. So the force which is experienced by one charge particle due to its neighboring charge particle is F. Let I be the unit vector along x-axis, then the net force on each charge from left to right. So we have to find what is the magnitude of force on this charge, magnitude of force on this charge, magnitude of force on third charge. So if I talk about the first charge is experiencing a force of repulsion due to second charge, force of repulsion due to second charge, force on 1 due to 2, plus it is also experiencing a force of repulsion due to third charge in this direction, that is force on first due to 3. That is, we are having force experienced by the first charge is equal to force on first charge due to second charge plus force on first charge due to third charge, that is 1 upon 4 pi epsilon naught q, because charge at first point is q, second point is also q, so q upon distance between these two charges is d, so d square plus 1 upon 4 pi epsilon naught, charge at first point is q, charge at third point is q, so q divided by distance between first and third is 2d. So 2d, and this resultant is along negative x-axis, that is minus I cap. So F1 I cap, that is, it will be negative. So we are having 1 upon 4 pi epsilon naught q square upon d square plus 1 upon 4 pi epsilon naught q square upon 4d square. And now taking common 1 upon 4 pi epsilon naught q square upon d square, we are left with 1 plus 1 by 4, and on solving it is having a value 1 upon 4 pi epsilon naught q square upon d square into 5 by 4. That means first charge is experiencing a force of 5 by 4, and taking this as F, 5 by 4 F in the negative side. So that means force on the first charge is equal to minus of 5 by 4 F I cap. So this is already clear to us. And similarly, if I talk about the third charge, now just making the space for the next solution, and if we are having a third charge here, Q. So it is experiencing a core force. This is third charge. It is experiencing a force of repulsion due to this second charge. This is second charge in this direction in along positive x-axis, and this is Q charge which is placed at first point. It is also experiencing a force of repulsion in the outward direction due to first charge. Similarly, now we are having force on 3 due to 1 plus force on 3 due to 2, and when we will solve it out, we will come out to be having a value of 5 by 4f, but along positive side. So force on 3 is equal to force on 1, but both are in opposite direction. Force on 1 is negative, force on 3 is positive. And when I talk about the second charge, it will experience a force of repulsion along this direction due to first charge, and it will experience a force of repulsion along this direction due to charge at third point. So that means Q charge will remain stationary. It is having equal forces, that is no forces are acting, because sum of forces is 0, because one force is in this direction, another is in this direction. So we are having answer minus 5 by 4 f I cap comma 0 comma plus 5 by 4 f I cap. So this is the C option, which is the correct option with this question. So two students A and B calculate the charge flowing through a circuit. The A concludes that 300 coulomb charge flows in 1 minute. So the conclusion which we are having is 300 coulomb of charge is flowing in 1 minute. That is Q is equal to 300 coulomb and time is equal to 60 seconds. But B concludes that 3.125 into 10 raised to the power 19 electrons flow in 1 second. So number of electrons which are flowing in 1 second are 3.125 into 10 raised to the power 19. So if it is measured that current in the circuit I is equal to 5 ampere, who is correct? A is correct or B is correct? We have to determine that. We know that I is equal to Q upon T. So this implies if we are having 5 is equal to Q upon 60, that is 5 multiplied by 60 is equal to Q is equal to 300 coulomb, and A has calculated the same thing, that the charge flowing is 300 coulomb. So that means A is correct. Now we need to determine whether B is correct or not. So Q is equal to NE. So as we have find that Q is equal to 300 coulomb, so we need to find that number of electrons. So 300 is equal to N into 1.6 into 10 raised to power minus 19. When we will solve this equation, we are having N is equal to 3.125 into 10 raised to power 19 electrons. So that means B is also correct. So we are having C option, that both A and B are correct. They have determined the same thing. The resistance of two wires having same length and same area of cross section are 2 ohm and 8 ohm respectively. If the resistivity of 2 ohm wire is this, then the resistivity of 8 ohm wire is, we are having two wires, two resistances, and they are having same length and same area of cross section. So we are having R1 is equal to 2 ohm and R2 is equal to 8 ohm. So rho 1 is equal to 2.65 into 10 raised to power minus 8 ohm meter. We have to calculate rho 2. So length of first is equal to length of second is equal to L, and area, they are having same area of cross section. Area of first is equal to area of second is equal to A. Then R1 upon R2 is equal to rho L1 upon A1 divided rho 1 L1 upon A1 divided by rho 2 L2 upon A2. So we can easily cancel L1 A1, because L upon A, we instead of writing L1 up or A1, we will write L upon A, and instead of writing L2 upon A2, we will write L2 L upon A. L and cancel. L upon A and L upon A are cancelled. So we are having R1 upon R2 is equal to rho 1 upon rho 2. So this implies R1 is 2, R2 is equal to 8, and it is equal to 2.65 into 10 raised to power minus 8 divided by rho 2. So it is 1 by 4. So cross multiplying, we are having rho 2 is equal to 4 into 2.65 into 10 raised to power minus 8. So on multiplying this, we are having rho 2 is equal to 10.60, that is A option. So 10.60 into 10 raised to power minus 8 ohm meter. So this was all calculation for question number 30. Again, it was an easy question. Then in a certain region, electric field E and magnetic field B are perpendicular to each other. So we are having two perpendicular fields E and B. An electron enters in the region perpendicular to the direction of both E and B and moves undeflected. So in this case, we are having a direct answer that when electron enters in the region of perpendicular electric and magnetic fields, then the speed of the electron is E upon B. So C is the correct option in this question. Then a test charge of 1.6 into 10 raised to power minus 19 coulomb is moving with the velocity v is equal to 4 I cap plus 3 k cap meter per second in a magnetic field 3 k cap plus 4 I cap Tesla. The force on this test charge is, so it was a question F is equal to Q v cross p. You only had to calculate v vector cross p vector, and you had to rearrange it as 4 I cap plus 3 k cap. When you will solve v vector cross b vector, you will find the answer to be 0. And how we have to solve it, it is in the class 11th, that how we solve the cross product, that is I cap j cap k cap, that is we are having value 403, again 403. When you will solve it, you will find this answer to be 0. Therefore 0 force is experienced by the test charge. Then in a series LCR circuit at resonance, the current is equivalent. We know in series we are having impedance Z is equal to under root of R square plus XL minus XC whole square. But at resonance, XL is equal to XC. Therefore, this term is 0. This is 0. So impedance is equal to under root of R square. Impedance is equal to R, and we know current I is equal to V upon Z for series LCR circuit, or here we can replace Z with R, so V upon R. So A is the correct option. In question number 33rd, then the frequency of an AC source for which a 10 microfarad capacitor has a resistance of 1000 ohm is, what is the frequency at which a capacitor having a capacitance C is equal to 10 into 10 raised to power minus 6, and the value will become capacitance capacitive reactance Xc is equal to 1000 ohm. So what we need to do, we had to put a formula, we have to use a formula Xc is equal to 1 upon omega C. So instead of writing omega, I can put 2 pi nu, because I was interested in calculating nu. So I will put nu over, I will take over here, and Xc over denominator. So nu is equal to 1 upon 2 pi Xc into C. So frequency nu is equal to 1 upon 2 pi. Instead of writing Xc, I will write 1000, and value of C is 10 into 10 raised to power minus 6, that is into 10 raised to power minus 5. So we are left with frequency is equal to 1 upon 2 pi into 10 raised to power 3 minus 5 is minus 2. So frequency is equal to 100 upon 2 pi, and it is 50 upon pi. So 15 upon pi hertz is the answer for the 34th question. Now, when it comes to 35th question, it may seem complex, but if we will solve this circuit, we will find that these three capacitors, first capacitor, second capacitor, and third capacitor, these are in parallel. Then we are having another parallel combination of three capacitors. These three are in parallel, then these three are in parallel, but these combinations are in series. So now, in parallel, we know in this parallel, we are having capacitances Cp is equal to C1 plus C2 plus C3. As the capacitors are identical, so here we are having net capacitance 3C. Again, here we are having net capacitance 3C. Now, these 3C capacitors are in series. So 3C, 3C. So 1 upon Cs is equal to 1 upon 3C plus 1 upon 3C is equal to 2 by 3C. So this implies Cs is equal to 3C by 2. So C is the correct option in 35th question. Then in 36th question, we are having the given figure shows IV graph of a copper wire whose length and area of cross section are L and A respectively. The slope of this curve becomes, so simply we are having slope is equal to y2 minus y1 upon x2 minus x1. So let me mark the slope. Here this is the slope. Let's say this is I2, this is I1, and this is V2, this is V1. Along y-axis we are having current. So here slope m is equal to, that is m is equal to I2 minus I1 upon x2 minus x1. Along x-axis we are having voltage, so V2 minus V1, so it is equal to 1 upon R. So if we will what will be the condition, or which statement is correct about the slope? It will less if the slope is less, if the length of the wire is increased. If we will increase the length of the wire, then its slope will decrease. Definitely, if we will increase the length of the wire, resistance will increase, so slope will decrease. So slope of this curve will become less if the length of the wire is increased. So A is the correct option for question number 36. Now, when it comes to the question number 37, when a potential difference V is applied across a conductor at temperature T, the drift velocity of the electrons is proportional to. So it is again very easy, because we know the formula I is equal to NEAVD. Drift velocity is directly proportional to amount of current flowing, and we know from Ohm's law I is directly proportional to V. So VD is directly proportional to the applied voltage. Drift velocity depends upon the potential applied. Then two identical thick wires and two identical thin wires are of same material and the same length form a square in three different ways, P, Q, and R, as shown. Due to the current in these loops, the magnetic field at the center of the loop will be zero in case of. So now in the first case we are having two thick wires. These are the directions of current. Now when you will place the thumb of your right hand in the direction, in this direction, and curl the fingers, your fingers will move inward. Now place the thumb of your right hand in this direction, and then curl the fingers, your fingers will come out at this point. So these fields are cancelling out each other. Here in this case, when you will place the thumb of your right hand in the direction of flow of current and curl the fingers, your fingers will move inward. Now place the thumb in the direction, in this direction, again curl the fingers, again your fingers will move inward. And now here in this case, in the third case where R combination, move the fingers of your right hand, place the thumb of your right hand in the direction, in this direction, and curl the fingers will move inward. And here now place the thumb in this direction and curl your fingers will come out at this point. So here and here the direction of the movement of fingers is opposite, therefore here the field will become zero, but here the direction is same, therefore field will never become zero. So A is the correct option, that is P and R only. Now, moving to the next question, we are having a circular current carrying coil produces a magnetic field B naught at its center. The coil is rewound, so we are having a circular current carrying coils. This is circular current carrying coil, and we know for a circular current carrying coil, we have magnetic field B naught is equal to mu naught I upon 2R. So what is R over here? We don't know. I will put it as R, and that is mu naught I upon 2R is equal to B naught. This is our equation number 1. Now we are having a coil is rewound so as to have 3 turns and the same current as is passed. We have just broke this coil over here from here, and we have taken 3 turns in it, so that we are having a new circle like this. So a circle with 3 turns, so its radius is changed. That means circumference of new circle, that is n number of turns, 3 number of turns, 3 multiplied by 2 pi r, is equal to circumference of the bigger circle, that is 2 pi capital R, because we have taken its radius to be capital R. So we can cancel 2 pi in each case. So we are having small r is equal to capital R by 3. So this is our equation number 2. What we need to find the new magnetic field at its center. So B dash is equal to mu naught I upon 2R. So it is equal to mu naught I upon 2. Instead of writing small r, I will write R by 3. So B dash is equal to 3 mu naught I upon 2R. So mu naught I upon 2R was B naught. So we can say 3 into B naught. So B dash is equal to 3 times B naught. So question number 39. For question number 39, we are having the value 3 times b naught, but in the answer key it is mentioned 9 b naught. I have no idea which is accurate. I believe that I have done it right. So you could take the second opinion, and if you know the other answer, you can leave a comment over here. So which of the following is statement is true? Out of these statements we have to find which is true. An inductor has infinite resistance in a DC circuit. No, it is not possible to have an infinite resistance in a DC circuit, and a inductor and a capacitor both cannot conduct in a DC circuit. It is again false. Inductor always conducts when it is a DC circuit. Then a capacitor can conduct in a DC circuit but not an inductor. This is again false. We always have done why capacitor blocks DC. So it is always a capacitor which blocks DC. So an inductor can conduct in a DC circuit but not a capacitor. So this is fine. So D is the right option. Then 41st question is the magnetic flux linked with the coil is given by this statement, where phi is in Weber, T is in second, and we have to calculate the induced EMF. So phi is equal to, sorry, induced EMF. E is equal to d phi by dt. So E is equal to d by dt of phi. Just derivate it. So when you will take the differentiation, 5t square plus 3t plus 16. I'm not going to give us a detailed instruction how to solve it. So on taking the derivative, we are having 10t plus 3. Put the value of t to be 5, then 10 into 5 plus 3. So very simple calculation, 53 volt. A is the correct option in this question. Then if a charge is moved against a Coulomb force of an electric field, then if we are having a charge which is moved against a Coulomb force of an electric field, then the intensity of electric field increases. Intensity of electric field decreases. Work is done by the electric field. So work is done by the external source. So definitely when we will move the charge against the Coulomb's force, then work is done by the external force. So D is the correct option. Then in question number 43rd, we are having a charge Q is located at the center of the circle of radius r. So this is the circle of radius r, and capital Q is placed at its center. Work done in moving a test charge from point capital A to point B, where A and B are lying are the points, opposite points on the diameter. So when we will move a charge Q naught from A to B, there is no work which is done, because work done in moving a charge over an equipotential surface is zero. So zero is the answer. Then a long solenoid carrying a current produces a magnetic field B along its axis if the number of turns in the solenoid is halved. So this is solenoid, and we know for solenoid B is equal to mu naught Ni. Now what will be B dash if n number of turns are halved? So mu naught N dash I dash. So N dash is equal to N by 2, and I dash is equal to 2I. See, number of turns in the solenoid is halved and current is doubled. So that means B dash is equal to mu naught N by 2 into 2I, and cancelling 2, again the formula is mu naught Ni. It is same. So there is no change. It will remain B. So B is the correct option. So this is about section B. And now when we are shifting to the section C, that is towards the assertion reason type questions. Sorry, it is again assertion reason are the part of section B only. So let us discuss the assertion and reason questions. We had to write A if assertion and reason both are correct, and reason is the correct explanation. We have to write B if assertion and reason both are true but reason is not a correct explanation. If assertion is true and reason is false, then C option. If assertion is false but reason is true, then D option. So first of all, we will talk about question number 45th, that is assertion. A bar magnet experiences a torque when placed in a magnetic field. Definitely, when a bar magnet is placed in a magnetic field, it always experiences a force. Sorry, it always experiences a torque. It is true, but what is reason? A bar magnet exerts a torque on itself. Does a bar magnet exerts a torque on itself? If it is the case, then a bar magnet would automatically have been rotated. So reason is false. So assertion is true, reason is false. C option. Question number 46. In a series LCR circuit connected to an AC source, resonance can take place. Definitely, in series LCR circuit, resonance happens. XL becomes equal to XC. Therefore, this is true. And at resonance, we know XL is equal to XC. But this is not explaining that how we can say that resonance occurs in AC source. How it happens, it is not explaining. So both the statements are true, but second statement is not a correct explanation of the first statement. Therefore, B is the correct explanation. Then when it comes to 47th, when a charged particle moves with velocity v in a magnetic field B, which are perpendicular, the force on the particle does no work. Definitely, there is no work which is done by the force. This is true. And the magnetic force is perpendicular to the velocity of the particle, because this no work is done by the no work is done on the particle, because magnetic field is perpendicular. Again true, and is a correct explanation. So A is the answer. Then induced EMF in two cells made of wire of the same length and the same thickness, one of copper and another of aluminium, is same. The current in copper coil is more than the aluminium coil. This is true, because copper is having a low value of resistivity and is better conductor than the aluminium. So aluminium will have a less current flowing through it. Resistance of the aluminium is more than that of the copper. So it is true, and it is explaining it. So option A is the right answer. Then 49th is, a transformer is used to increase or decrease the AC voltage only. Yes, transformers works on the principle of mutual inductance, and principle of mutual induction could only be possible if there is a variation in the value of current regularly. Without variation in the value of current, mutual induction is not possible. So a transformer never works on DC circuit, it always work on AC voltages. So transformer is used to increase or decrease the AC voltage only, not DC voltage. So transformer works on the basis of mutual induction. Yes, it is also true, and it is explaining the given assertion. So it is a correct explanation. So A is the right option. Now, when it comes to the 50th question, C section, two charged spheres A and B having their radii in the ratio 1:2. So radius of first R1 is equal to x, radius of second is 2x. They are connected with the conducting wire. That is, charge on A is equal to saying charge on 1 is equal to charge on 2 is equal to Q. Then we have to find the ratio of surface charge density. We know surface charge density is equal to charge upon area. Area of sphere 4 pi r square, r1 square I will write, and sigma 2 is equal to q upon 4 pi r2 square. So sigma 1 upon sigma 2 is equal to q upon 4 pi r1 square divided by q upon 4 pi r2 square. Q and q cancel, 4 pi cancel. It is equal to r2 square multiplied by 1 upon r1 square. So sigma 1 upon sigma 2 is equal to r2 upon r1. R2 is 2x and r1 is x whole square, and we are left with 2 square, which is equal to 4. That is, sigma 1 upon sigma 2 is equal to 4. So D is the correct option for 50th question. Now 51st question is, a current carrying square loop is suspended in a uniform magnetic field acting in the plane of the loop if the force on one arm of the loop is F and the net force on the remaining three arms of the loop will be. See, if we are having this square loop, it is placed in a magnetic field, and this is the direction of flow of current. So we know at this phase we are having same line of action for the equal and opposite forces. So net force along this direction is 0, but the force which is acting in this direction, which is taken positive, and the force which is acting on this line is negative, minus F. The line of action is different. So if line of action is different, then it forms a couple. So net effect is this, the resultant of these two forces is 0 plus minus F. So answer is minus F. So the resultant net force due on the remaining three arms will be minus F. So D is the right option. Now when it comes to case study, it was quite simple. We were having two batteries of EMF E1 and EMF E2. These are connected in the opposite sense, and the internal resistances are R1 and R2. In the first question, we had to find the equivalent EMF. So in this case, because these are connected oppositely, so we are having the resultant EMF as E1 R2 minus E2 R1 divided by R1 plus R2. So this was the value of the equivalent EMF of the combination. And for the terminal B to be negative, if we want B to be negative, look at this. B will become negative if E2 R1 is less than E1 R2. So B is the right option in question number 53rd. The current in the internal circuit is, so what is current? We know current is equal to E upon R. So it is simply E1 plus E2 upon R1 plus R2. And the equivalent internal resistance of the combination is, because resistances are seen to be connected in parallel, so the equivalent resistance will be R1 R2 upon R1 plus R2. C is the correct option. So this is all about your question paper. I hope you have analyzed it thoroughly, and I believe that overall the question paper was quite easy, except few questions which needed a little more attention and time in order to perform some calculations. Otherwise, it was all based on the concepts, on the general concepts, and was easy. So for according to my point of view, the overall question paper was quite easy.